Welcome back, everybody. In this video, we're going to learn about how to do simplifying of fractions, and along the way, we'll need to know about how to factor numbers. And so let's get started. So starting with finding the factors of a number, what the factors of a number are the numbers that you'd multiply together to get that number. So for example, in 63, 63 is 9 times 7, and so 9 and 7 are factors of 63. Note that numbers can have a lot of factors. For example, you could look at 63 as also 3 times 21, and so 3 and 21 are factors. Okay, of course, also any number has 1 as a factor. For example, 17 is 1 times 17. Because every number times 1 is equal to itself, you could say that 1 is a factor for every number. To save time and energy for the rest of this video, I'm going to skip that. Okay, so from now on, just know that every factor has every number has 1 as a factor. Okay, the process of finding factors is called factorization or factoring a number. Okay, couple more definitions. Prime numbers versus composite numbers. Composite numbers first, it says, a natural number greater than 1 that is not prime, so it's a prime number. A prime number is a number whose factors are only 1 in that number itself. The numbers 2, 3, 5, 7, and as shown here in this list, are the first several prime numbers. The big idea is it possible to come up with an interesting factorization of a number or not? Okay, 27 is 9 times 3, right? And so this has a factorization besides just 27 and 1. So this is not prime, it would be composite. On the other hand, a number like 29, 29 is what times what? It's 29 times 1. Okay, as I'd mentioned before, that's true of every number. Just multiply by 1, you get that number itself. Is there any other way of getting 29 via multiplication by whole numbers? And there's not. So 29 is an example of a prime number. Knowing if numbers are prime or composite is helpful in producing factoring and also to help us simplify fractions. Okay. For this next couple of examples, we just want to decide if each number is prime or composite. And by explain, we just mean tell how we made that decision. Okay, 16 is composite. Okay, an example would be that it is 8 times 2. Okay, if you said 4 times 4, then you're also right. Okay, as long as we have something to say besides 16 times 1. 31 is prime because 31 is only 31 times 1. And there's no other way to arrive at 31 by multiplying by whole numbers. Okay, 49 is composite. And that's because it is 7 times 7. Okay, so that makes it composite. Okay, out of all the different factorizations there are for a number, the one that is the prime factorization is the one where all of the factors are prime numbers. So for example, if you write 12 as 4 times 3, that is a factorization, but not the prime factorization. If you write 12 as 2 times 2 times 3, that is a prime factorization because 2 and 3 are prime numbers. Okay. Finding the prime factorization is finding the factorization where all the factors are prime numbers. That is, you've kind of broken down the number as far as you can and no further. Okay, so finding the prime factorization of each number. There's a couple of different ways of showing you the work. So I'll show you several and you can pick one you like. One way of doing it is through kind of a tree diagram or the roots of a tree diagram. So 30 is 10 times 3. If you said 6 times 5, that's okay. Okay. We'll talk about more of that in a minute. 3 is a prime number, but 10 can be broken down further. It is 2 times 5. And none of 2, 5, or 3 can be broken down further. 2 times 3 times 5 is the prime factorization of 30. Let's try that again. 36. 36 is 6 times 6. And each of those 6's is 2 times 3. So here we have 2 times 2 times 3 times 3. Or if you write that using exponents, that's 2 squared times 3 squared. Okay? 105. 105 is divisible by 5. So that is 21 times 5. 5 is prime, but 21 isn't. 21 is 3 times 7. So we'll have 3 times 5 times 7 for our prime factorization. Okay. So we have more examples. Go back actually. Okay, so this was one way of showing the work. Another way of doing this is by repeated division. So let me show you that. I'm going to use 36 for that example. So 36, start with the lowest prime number, which is 2. 36 is divisible by 2. If you divide through by 2, you'll get 18. Is 18 divisible by 2? Yes, it is. So let's divide by 2. 2 goes into 18 9 times. Is 9 divisible by 2? No. What is the next prime number? The next prime number is 3, so we will divide through by 3. 3 goes into 9 3 times, and the quotient here is a prime number. And so reading along the outside, we have 2, 2, 3, and 3, which is our prime factorization for 36. Okay, we'll try that again. So let's try that with 60. Okay, so 60, you could do the tree diagram if you like, or we could try repeated division. Let's try repeated division. 2, the first prime number, 2 divides into 60 30 times. 2 divides into 30 15 times. 2 doesn't divide into 15. The next prime number is 3. 3 goes into 15 5 times, and 5 is prime. So looking around the outside, our prime factorization is 2 times 2 times 3 times 5. All right. All right, so a natural question that comes up is, how do you know if you're doing it right? That is, if you look at 60 and you say, okay, well, I didn't do that. I said 2 times 30 or 4 times 15. And the thing is, what's nice is that although the work may look different, the final answer you get is the same. So let's say for 60, I looked at that and I thought that's 5 times 12. And then for 12, you're going to ask yourself, okay, well, is that 2 times 6 or is it 3 times 4? And the short answer is that it doesn't matter. So just pick one. So I'm going to go with 3 times 4. 4 is 2 times 2. Looking down at the ends of the roots here, we'll have 2 times 2 times 3 times 5. And that gives us our same factorization. If you looked at 60 as instead 15 times 4 or 30 times 2, you're going to get the different looking scratch work perhaps, but the same final answer. Okay, so the next thing that we want to do is we want to look at some divisibility tests. What divisibility tests are for is a way to check and see if a number is divisible by another number without actually doing the division. So we actually already had used one back here when I said, okay, 105 is divisible by 5. I know that 105 is divisible by 5 because it ends in a 5. Okay, so let's take a look at these divisibility tests. Okay, so first of all, divisibility test for 2. If the last digit is a 0, 2, 4, 6, or 8, you have an even number, and so your number is divisible by 2. Examples, 24,518, that's divisible by 2. 63,805, not divisible by 2. Okay. 3, this one is kind of an interesting test. If the sum of the digits is divisible by 3, you get a number that's divisible by 3. For example, 27, 2 plus 7 is 9. Okay, 2 plus 7 is 9, and 9 is divisible by 3. So this one's divisible by 3. For the next one, 5,181, 5 plus 1 plus 8 plus 1, that's 15, and 15 is divisible by 3. And so 5,181 is divisible by 3. For 2,131, 2 plus 1 plus 3 plus 1, That's 7. 7's not divisible by 3. So 2,131 is not divisible by 3. 169, if you add up those digits, 1 plus 9 is 10, plus 6 is 16. 16 not divisible by 3. Okay, for the test for 4, if the last two digits form a number that's divisible by 4, you have a number that's divisible by 4. So for example, 5,124, the last two digits are 24, and that's divisible by 4. So 5,124 is also. 348, the last two digits are 48, so you get a 348 is divisible by 4. For 722, 22 is not divisible by 4, so 722 is not. For 914, 14 is not divisible by 4, so 914 will not be. Okay, divisibility test for 5. If the last digit is either 0 or 5, you have a number that's divisible by 5. So 35 and 400 are both numbers that are divisible by 5, but 53 and 87 are not. Okay, the test for 9 is really similar to the test for 3. You add up the digits and see if you get a number that's divisible by 9 or not. 171, 1 plus 7 plus 1 is 9, which is of course divisible by 9. So 171 is divisible by 9. 684, 6 plus 8 plus 4, that's 18. And 18 is divisible by 9. So 684 is divisible by 9. I'll leave 144 for you to check. For 39, 3 plus 9 is 12, and 12 is not divisible by 9. It is divisible by 3, though, so it does pass the 3 test. 78, 7 plus 8 is 15. 15 is not divisible by 9. The divisibility tests can be helpful if you're trying to determine whether a fraction can be simplified or not. For example, if you were, we haven't talked about simplifying fractions, we're about to, but just to give the feeling, let's say that you're trying to decide if 24/87 could be simplified. Okay, so could 24/87 be simplified? I know 24 has factors like 2's and 3's and stuff, but maybe 87 is prime. On the other hand, if you remember that 8 plus 7 is 15, then you could say, okay, well, I know that this 87 is divisible by 3, and 24 is divisible by 3. So that would be how we would use the divisibility test to help us simplify. Okay, so that said, how do you simplify fractions? Little words first. Writing fractions in simplest forms. Fractions that represent the same portion of a whole are called equivalent fractions. Okay, so as an example, 1/2 and 2/4 are equivalent fractions. They represent the same value, although they do look different. Okay, there's many equivalent forms of a fraction. A special form is called the simplest form. The simplest form of a fraction is also called being in lowest terms. It's when the numerator and denominator have no common factors other than 1. So as examples, 10/24, 10 and 24 both have 2 as a factor, so not simplified. 9/51, not simplified. Both 9 and 51 are divisible by 3. -84/90, 84 and 90 are both even numbers, so that's not simplified. Same with 64/28. Both of those are divisible by 4, actually, so this thing is not simplified. Okay, on the other hand, 31/49, those don't have any common factors other than 1. -50/27, no common factors other than 1. You can check that with the 3/5 and 12/17. They don't have any common factors other than 1. Okay. When we say simplified or in lowest terms, you may also hear that referred to as reduced. That was the term when I was in school, was reduce the fractions, but you may hear it called by different things. Simplify, reduce, or write your fractions in lowest terms. But all of those mean the same thing. That is, we don't want to have the numerator and denominator having common factors other than 1. Okay, so how do you make that happen? How do you make them be in simplest form? To write a fraction in simplest form, you can write the prime factorization of the numerator and denominator and then divide by all the common factors. So the best way to see how this goes is with examples. So let's try that with a couple. So for 50 over 22, I'm going to find the prime factorization of 50. 50 I know is 2 times 5 times 5. And 22 is 2 times 11. So I formed the prime factorization of both of these values, the numerator and denominator. Divide both by all common factors. So the numerator and denominator are both divisible by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So I've divided the numerator and denominator both by 2. This will give us 25 in the numerator and 11 in the denominator. Now 25 over 11 no longer has any common factors in the numerator or denominator. Okay, so you'll notice that I formed the prime factorization for this because that's more or less what the written directions say to do. If you are comfortable not doing that, then there's nothing wrong with doing following mathematically. If you say, okay, well, 50 and 22 are both even, so let's divide through by 2. 50 divided by 2 is 25. 22 divided by 2 is 11. This gives us 25 over 11. Okay, a lot of books that you'll see will recommend forming that prime factorization and then dividing out or canceling out those common factors. If you don't need to do it to get the division done in your head, then you're welcome to not form the prime factorization, just start dividing common factors. All right, so as another example of that, for 9/90ths, I know I don't need to factor 9 into 3 times 3 and 90 into 3 times 3 times 2 times 5, because I know that both 9 and 90 are divisible by 9. I'll write 9 as 9 times 1 and 90 as 9 times 10. So now we can divide both numerator and denominator by 9, and that will leave us with 1/10. Okay, nice and simplified. For 35 and 75, if you wish, you can divide or find the prime factorization for both. Here, I don't really feel the need, so let's not. Divisibility test, though. 35 and 75 both end in a 5, so that tells me they're both divisible by 5. So let me factor the 5 out. 35 is 5 times 7, and 75 is 5 times 15. Okay? So now the numerator and denominator are both divisible by that 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And that leaves us with 7/15. Okay, so that fraction is now in simplest form. All right, so next we just have a couple of other examples where we're simplifying fractions. So starting with 10 over 42, this time just for fun, I will go ahead and form the prime factorization. 10 is 2 times 5. I know that 42 is 6 times 7. Here's an example of where knowing the multiplication tables helps you, right? So 42 is 6 times 7. 6 is, of course, 2 times 3. So we have 2 times 3 times 7 in the denominator. Okay, we'll divide out a 2 from each of the numerator and denominator, and that will leave 5 over 21. Okay, next up we have 9/27. So 9/27 is the same as 9 times 1 over 9 times 3. Here there's a common factor of 9 that can be divided out. 9 divided by 9 is 1. 9 divided by 9 is 1. And so we're left with 1/3. Okay, 8 over 36. So here I can look and I can say, okay, well, both of these are divisible by 2. So let's divide through by 2. 8 divided by 2 is 4. 36 divided by 2 is 18. 4/18. One thing you want to be careful of in simplifying fractions is to make sure to simplify all the way. That is, after you've divided out a factor, check and see, okay, is there more to be divided out? 4/18 is not simplified. And if you look back, you probably said, well, why didn't you divide through by 4? I didn't so that I'd have an example for you, okay? So 8/36, I divided out a 2 first. We can divide out a 2 again. So let's do that. So 4 divided by 2 is 2, 18 divided by 2 is 9. So this will give us in the end 2/9, which is what we would have had if I had divided through by 4 in the first place. Okay, so the point of this example really is just to make sure that you simplify all the way, divide out all the common factors you possibly can. Okay, the next one has some letters in it, but we'll work with it in the same basic way. We have 7a cubed, which is 7 times a times a times a, and that's divided by 56 times a times a, 56a squared. So taking care of the number part first, I know that 7 times 8 is 56, so we'll divide the numerator and denominator by 7. So we'll end up with 1/8 for the constant part. And then we can divide out 2 factors of a from the numerator and denominator. So what's left up top, we have 1 times a. Down below, we just have an 8. Okay, so then this will give us a over 8. Okay, so that's the end of that example. All right, so that takes us to the end of this video on coming up with factors, prime factorization, and then simplifying fractions. In the next video, we'll work on how to do multiplication and then division of fractions. In the meantime, have a great day.